name is Lin, and I'm part of group B13 with Nitou, Makidi, and Chen, Guanlin, and we will be presenting brown adipose tissue and its thermogenic capabilities. So the introduction is that brown adipose tissue generates heat, proven by Richard in 2011. Brown adipose tissue's thermogenic capabilities is due to its well-developed mitochondrion with uncoupling protein 1, otherwise known as UCP1, also discovered by Richard in 2011. And UCP1 is a protein that uncouples mitochondrial respiration from ATP synthesis, discovered by Rousset in 2004. Next, we have Nitou Makidi with the data and results.
So, here is figure 1. After cold exposure, participant skin temperature was reduced by approximately 3.8, give or take 0.4 degrees Celsius. Without change in core body temperature, resting energy, VO2 and VCO2. VO2 and VCO2 are measures of the body's ability to consume oxygen and produce carbon dioxide. Protocols A and B use radioactive analog structures of glucose and palmitate, respectively, to trace indicators and deposits found in brown adipose tissue. Next, in Table 1, displays participants' average body temperature, metabolites and hormones, glucose and non-esterified fatty acid, also known as NEFA, appearance rates at both warm and cold temperatures. The significance of values from all participants were the average from both protocols A and B. Since protocols A and B have the same procedure, the difference is in the rate of appearance of glucose and NEFA in brown adipose tissue. Next, we will have Guanlin Chen.
Okay, from part A in figure 3, we can see that the PET, CT, and fusion scan of views of this thoracic junction in one of our participants, and the red circles here indicates the location of BAT. From part B and part C in figure 3, we can see that the net NEFA uptake by using, we can see the net NEFA uptake by using the FTHA as a fatty acid tracer. The uptake of NEFA will be the most active in Longus coli and BAT. Yeah, from part D. Part D is the coronal view of the whole body FTHA uptake during cold exposure, and we can see in cold conditions our liver and cervix will uptake NEFA most actively. Yeah, next. From the first 6 chart in figure 4 show the first 500 seconds of C11 radioactivity in different body tissue in our body. And the radioactivity of C11 is the marker of tissue oxidative or non-oxidative metabolism in our body. And from part B and part D, we can see that the temperature do influence the radioactivity of C11 in BAT and Longus coli, but it will not. But temperature will not influence the radioactivity of C11 in some body tissues like aorta or SC adipose tissue. And part G and part D show the decay slope of C11 activity in our body tissue like BAT and Longus coli. And from this we can see that the temperature do influence the decay slope of C11 activity. And that's next we'll have Jonathan to discuss the conclusion we have.
So in conclusion, the paper proves that there are brown adipose tissue in adult humans, and that these brown adipose tissue deposits are activated when the subjects are exposed to cold temperature. So how does this paper relate back to the biology we learned in Bio 1510? Well, in Biology 1510, we learned that through oxidative photophosphorylation, the mitochondrion generate ATP through the electron transport chain. The electron transport chain will take electrons down and then use that energy coupled with the proton motive force in the intramembrane space to produce ATP. However, UCP1 is a proton carrier and deposits protons in the mitochondrial matrix, and thus depriving ATP synthase the proton motive force necessary to make ATP. Thus, when electrons go through the electron transport chain, the energy is not made into ATP, and instead generates heat. And this heat is the basis of the brown adipose tissue's thermogenic capabilities. So, just a brief summary, UCP1 will take these protons and carry them into the mitochondrial matrix. And then when that happens, you don't have enough of a proton motive force to generate the ATP. So instead, when electrons go through the electron transport chain, all of the energy has no other way of release, so it's released as heat. And that's the essential backdrop. So our take-home message for this paper is that brown adipose tissue produces heat without shivering in cold temperatures due to uncoupling protein 1's uncoupling oxidative respiration, and thus it produces a cycle of heat. And these are our works cited pages.